Now it's time for the third video in the Math for Chemistry section, and this video is on algebra. As I've stressed several times, chemistry is a mathematically based science. What's really nice is, for us, it's going to essentially be Algebra 1. And what I'm going to do is give you 3 word problems to begin with. And if you can do these 3 problems, you can do the math for chemistry. So here is problem number 1. You have 37 people in the room. Everybody in the room is to get 124 M&Ms. How many total M&Ms are needed? Stop, figure it out, come back, check your answer, and then we'll move on. Oh, write your answer down because we're going to come back to it later. Go. And the answer is 4,588 M&Ms are needed. Okay, problem number 2. Now you have a pile of 3,848 M&Ms. 26 people that share these M&Ms equally. How many M&Ms does each person get? Stop, figure it out, write the answer down, come back, check it, go. And each person will get 148 M&Ms. Problem number 3. Now your pile of M&Ms is 6,636. You're going to give 158 M&Ms to people as they pass by you. How many people are going to get M&Ms? Once again, figure it out, write it down, come back, and then we are going to go over the 3 problems. Go. And the answer here is that 42 people will receive M&Ms. So how did we do this? We used Algebra 1. We have a simple equation. The number of people times the number of M&Ms per person equals the total number of M&Ms. There are 3 variables here. Number of people, number of M&Ms per person, total number of M&Ms. If you know any 2 of these 3, you can calculate the third. So let's go through the 3 problems. The first one, where you get the 37 people, each to get 124 M&Ms. You start with your equation. Figure out what you know, the number of people you know, the number of M&Ms per person you know, but you don't know the total number of M&Ms. So plug in what you do know, and in this case just multiply the 37 by the 124 and you get the answer. Let's go to the second problem, where you had the 3,848 M&Ms to be divided amongst 26 people. Once again, start with a basic equation. Fill in what you know. You know the total number of M&Ms. You know the total number of people. You're looking for the M&Ms per person. Plug in the values. In this case, you want to divide both sides by 26 people, so 26 people will cancel on the left-hand side. Now you have this. Now you just simply do the math, and you get 148 M&Ms per person. For the third problem, you know the number of M&Ms, you know the number of M&Ms per person. Start with your equation, highlight what you know. We know the total number of M&Ms, we know the M&Ms per person. We're looking for the number of people. Fill in the numbers. In this case, we're going to divide both sides by 158 M&Ms per person, so it cancels on the left. This is the equation you're left with. You have isolated the number of people, so you can do the math, and you get 42 people. So this is a simple A times B equals C problem. 3 variables. If you know any 2, you know the third. So if I know A and if I know B, then I just multiply them to get C. If, however, I know A and I know C, I want to get B by itself. So I divide both sides by A, so the A cancels on the left, and I'm left with B equals C divided by A. But what if I happen to know B and C? Then I divide both sides by B, cancels on the left, and I get A equals C divided by B. You don't need to memorize all of these equations, but you do need to be able to manipulate the A times B equals C. Now in chemistry, or actually any of the sciences, you'll frequently have an equation of the formula G equals H divided by I. Now notice this is still 3 variables, G, H, and I. If I know any 2 of these variables, I can calculate the third. So if I happen to know H and I just do the math and I'll get the value for G. If, however, I know G and I, then I want to get H by itself. I multiply both sides by I, so the i's cancel on the right, and I'm left with G times I equals H. The third possibility is I know G and h, and I want to calculate I. From history, this is the setup that causes the most problem among students. Here you want to get I by itself in the numerator. So you have to multiply both sides by I so they cancel on the right, and you have this equation. But the I isn't isolated yet. So you divide both sides by g, and you end up with I equals h divided by g. Now there is a shortcut for this. If you happen to know g and h, then if you swap out I and g, you come up with the same equation as if you derived it. So now 3 more problems, and then we'll wrap up the video. And it turns out that there is a quantity called density, and density is defined as follows. The density of something is defined as the mass of this object divided by the volume of the object, frequently abbreviated D equals m divided by v. If you know any 2 of these variables, you can calculate the third. So here's the first practice problem. You have some lead. As a matter of fact, you've got 200 milliliters of lead. That 200 milliliters of lead has a mass of 2,268 grams. What's the density of lead? And don't forget the units. Stop, figure it out, and then come back. Go. And the correct answer is 11.34 grams per milliliter. How did we get this? We started with the question. We chose the equation we felt would be useful. We identified what we know. We know the mass. We know the volume, but we don't know the density. Plugged in the mass, plugged in the volume. The D is isolated by itself, so just do the math, and you get 11.34 grams per milliliter. Let's go to problem number 2. Osmium is the densest element with a density of 22.59 grams per milliliter. I hand you 250 milliliters of osmium. What's the mass of the sample? Stop, figure it out, come back. Go. And the correct answer is 5,647.5 grams. Once again, start with the question. Pick the appropriate equation. Identify what you know. We know the density, we know the volume, but we don't know the mass. Plug in the values that you know. So you plug in the density, plug in the volume, multiply both sides by 250 milliliters so it cancels on the right. So now you have the mass isolated. You do the math, and you get 5,647.5 grams for that mass of osmium. The final problem of this video. You have some gold. Gold's got the density of 19.30 grams per milliliter. If you could gather all the gold that has been mined throughout recorded history, it would weigh 1.71 times 10 to the 11th grams, or approximately 171 billion grams. What's the volume of this much gold? Stop, figure it out, then come back and we'll go over it. And don't forget, the 1.71 times 10 to the 11th is just a number. Just because it's in scientific notation, it's nothing special, but don't convert it to standard form. Go. And the answer is 8.86 times 10 to the 9th milliliters. Start with the question. Choose the appropriate formula. Identify what you know. Density, mass, looking for the volume. Plug in what you know. Density, plug in the mass. Multiply both sides by V so it cancels on the right, but you want to get V by itself. So divide both sides by 19.30 grams per milliliter. Now that cancels on the left. The V is by itself in the numerator, so do the math, and you get 8.86 times 10 to the 9th milliliters, which is enough to cover the football field to a depth of 1 meter. And I'm sure you remember that 1 meter is just a touch over 3 feet deep. What if you wanted to use the shortcut? Well, just switch the V and the 19.30 grams per milliliter. You now have this, which is what we had before. You get the same answer. So to review, math is essential to understanding chemistry. However, simple Algebra 1 is what we use 95% of the time. You need to manipulate 2 generic equations, A times B equals C, and for each of the generic equations there are 3 possibilities. For this one, A times B equals C, A is C divided by B, B equals C divided by A. But you don't need to memorize these 3, because if you understand A times B equals C, you can derive the other 2. The second generic equation is G equals H divided by I. So you start with that. You can derive this. and you can then derive this. And shortcuts are okay if you understand how to work the equation, because if you can work the equation, if you forget the shortcut, you can still get to the correct answer. So this does it for video number 3 of section 1. In the next video, we're going to deal with an application of algebra, a very specific application. We're going to talk percentages.